In this video, we're going to take a look at finding a distance between two lines. So, whenever I talk about finding a distance between two lines, I'm assuming something to be true. And that thing that I'm assuming to be true is that these two lines are parallel. The reason for that is because if I want to find the distance between two non-parallel lines, so assuming they're in the same plane, that means that they intersect. And so, how do I find a distance between two lines that intersect? Well, if they intersect, the shortest distance between them is, of course, just that intersection point, 0, right? So I'm going to find the distance between two parallel lines. So I've randomly generated two of them that we're going to use here. It's going to be the line y equals negative 2x plus 6, and the other one will be y equals negative 2x plus 8. So we're going to sketch these out really quick, and then we're going to get an idea of what our process is going to be moving forward, and then we'll actually go about finding this distance. So here is my graph. I'm going to graph the line. I'll graph them both in the same color, I guess. So negative 2, so kind of steep, negative slope. I have one that intersects at 8, so we're going to put it about here. And then the other one is going to intersect at 6, so a little bit below it. We'll put it here. That wasn't a good line. That was a bad line. Try again. Okay. Maybe these points don't add up exactly, but they're close enough. So I have my two lines here. They're parallel to each other because they have the same slope. I'm going to try and find the distance between them. So when I talk about finding distance between these two lines, what I mean is the shortest distance, which will be the same distance at any point along here. Right? It doesn't really matter where I'm looking. As long as I'm talking about finding this perpendicular distance. My goal is to find the shortest distance between these two lines, which we discussed when we talked about finding the distance between a point and line, is just this perpendicular distance. So here is my process. My process is going to be, because it doesn't matter which point I use, but number one, I need to pick a point that I want to use. So I'll pick a point on one of the lines, and then step 2 is find the distance between a point and a line. Find the distance between a point and a line. So as soon as I pick that point, a point and a line, as soon as I pick that point, I can't do this at the same time. Find the distance between a point and a line. As soon as I pick that point, this just turns into the same problem that I had before, which is finding a distance between a point and a line. So part A, finding this distance, will be find the perpendicular line. Find perpendicular line. Part B will be find intersection point. And then part C will be find the distance using a distance formula. Find distance. Okay, so let's go ahead and knock this out then. The first thing we're going to do is find this point. So I need to pick a point just along here anywhere. It doesn't matter which one I use. There are a couple of obvious ones I think that I would pick just to make my life easier. For example, whenever I can pick a point that has a 0 in it, I'm going to pick that one. So in this case, this is the point 0, comma 6. Okay, I'm going to use that point. So this is part number 1. The point that I'm going to use is, and actually let me list out all my information here. My two lines are y equals negative 2x plus 6. My second one is y equals negative 2x plus 8. And then my point that's on this line here, my point is the point 0, comma 6. And so really my goal is now to find the point that's on the other line. And so I'm now going to move on to part number 2, which is find the distance between this point and this line here. So I need to find my perpendicular line. So the way that I'm going to do that is I need to find the equation of this line here that goes through this point and then is perpendicular to both of these lines. So what I'm going to do is, it's easy enough because I have this point and I know what the slope is, because two perpendicular lines always have opposite reciprocal slopes. So it has opposite reciprocal slope to negative 2 would be the slope of 1/2. And so since I picked the point 0, 6, I also know the y-intercept as well. So my perpendicular line, I actually have to put very little work into this. Perpendicular line will be the line y equals 1/2 x, 1/2 x, and then plus 6, because I know what the y-intercept is. Okay, so I have my perpendicular line, which is great. So I can move on to the next part, which is find that intersection point. Now, what have I not used? Green? Okay, so find the intersection point here. I'm basically solving the system. I have to be careful because I need to pick the correct lines here. I obviously want my perpendicular line, y equals 1/2 x plus 6. But then I need to pick the line that I want it to intersect. I already know this intersection point. I need to find this other intersection point. This is the line y equals -2x plus 8. So I need to solve this system, -2x plus 8. So again, since these are both in slope-intercept form, I have them both solved for y, so they're ready-made for substitution. So I'll just solve this using substitution. 1/2 x plus 6 will be equal to -2x plus 8. Because these are both equal to y in this situation. And so when I solve this, I'll get 5/2 x over here equals 2. So x will be equal to 4/5. A lot better than last time. If I plug this back into either of these equations, doesn't matter which one, I'll get that y is equal to, all right, if I plug it in here, this will be -8/5. This is 40/5, so 32/5. And I can confirm that if I plug that in over here as well. So 4/5 times 1/2 would be 2/5, plus 30/5 would be 32/5. Great. So my intersection point then is the point 4/5, 32/5. So now I just need to go about finding this distance, which I can do. I just need to find a distance between the 2 points 0, 6, which is the one that I picked initially, and this new one that I just found, 4/5, 32/5. So I'll use my distance formula to find this distance. So this will be the square root of, and then my change in x. And this is why I picked the 0 here, because 0 is a nice number to work with. 0 minus 4/5 squared plus, and the distance between, or difference between 6 and 32/5. So 6 minus 32/5, that quantity squared. Okay. When I simplify this, this is going to be, let's see, the square root of, well, just 4/5 squared plus, and then, all right, so this is 30/5 minus 32/5, so that's just -2/5 squared. That worked out well. Okay. I'll square both of these. Man, I'm going to use my calculator. This is great. This is 16/5 plus 4/5, which is just the square root of 20 over 5. Wait a second. That's bad math. Oh, I can do this. 25. I forgot to square the denominator. 25, perfect. So when I square root this then, what I get is the square root of 20 over the square root of 25, which is just 5. And I can simplify this to be, so there's a perfect square, it comes out 24. So this is 2 root 5 over 5. Now I will have to use my calculator for this part. What does that come out to be approximately? So if I take this divided by 5, I get the value of 0.89. So this is about 0.894. And so the question is, does that make sense in the context of my problem? And the answer is yes. Because, so if I look at this this vertical distance between these two, the difference here is 2. However, because of the steepness of these slopes here, this line then will obviously have a much shorter distance than 2. So it should be a small number. 0.894 makes sense to me, I think. It does seem a bit small, but I'll trust it. I'm just going back and checking my math real quick. It appears that this is just fine. Okay, so let's recap real quick what I did here. So finding a distance between two lines ends up just becoming the same process as finding a distance between a point and a line. Because any point along these lines, it doesn't matter which one I pick, I'll always have the same distance between the two lines. So I just need to pick a point first. I picked this point 0.06 because it was easy, because it is the y-intercept, and so it has a value of 0 in it. And then I just turn this into the find the distance between a point and a line problem. I found my perpendicular line, which is the shortest distance. I found my intersection point using my perpendicular line and solving this system. And then once I did that, I just found the distance between these 2 points and got the value of 0.894. But the one I really care about is this one right here, my exact value of 2 root 5 over 5. And so this same process is what's going to work for finding me a distance between any two lines, or any two lines that are parallel to each other. And so I can go ahead and use this now whenever I have future problems that ask for the same thing.